So far, this unit has emphasized two important ways that the results of statistical analyses can be influenced strongly. First, by the way attributes are quantified, as in the volleyball problem. And second, by the way constructs are operationally defined, as in the summer jobs problem. But statistical analyses also can be influenced by judgments about the types of quantities that various data represent. So, in class, your task was to create a classification scheme for sorting out examples of as many different kinds of quantities as you could from a current newspaper, such as USA Today. The quality of your classification system should be assessed based on its perceived usefulness to other students in the class, to help them be aware of the many different kinds of quantities that we are likely to encounter throughout the remainder of this course. So, your classification system should include illuminating examples, and it also should help to clarify important similarities and differences among the different kinds of examples that you consider. In addition to the examples of quantities that you found in your issue of USA Today, you also were given this list, which shows more examples of quantifiable attributes that occur in everyday situations. You should have noticed that, sometimes, the same term is used in several different contexts. But, in these different contexts, terms might have somewhat different meanings. Notice that, for our purposes in this course, none of these attributes will be referred to as quantities until they have been defined in ways that are measurable. Here are 4 questions that you could ask for nearly any of the examples where the same term is used in more than one context. 1. For two people in a gymnasium, how can you compare their flexibility without assigning measures to either of them? 2. For two people in a counseling clinic, how can you compare their flexibility without assigning measures to either of them? 3. How are your answers similar and different for questions 1 and 2? And 4. How could you measure the flexibility of people in questions 1 and 2? Notice that, for a given attribute, like flexibility, it often is possible to compare occurrences of the attribute without converting any of these occurrences to quantitative measurements. In general, measurements have 2 parts. The first tells how much, or how many, or what kind. And the second tells of what. It tells the unit that is being used to measure. For example, this table is about people or tasks in a gymnasium. Notice that the 2 parts of each measurement are shown. But, for the last 3 measurements, no information is given to answer the questions, how many, and, of what. So, you should stop this video at this point and try to answer these questions for yourself. Notice that your answers to this question are not restricted to using standard units, like miles, minutes, pounds, or calories. You also can use units that involve other observable and countable things, like steps. But beware. Some observable and countable attributes can be combined to operationally define constructs that you want to measure. But other observable and countable attributes are just indicators, not measures. What's the difference? Clocks are used as indicators or elapsed time. But the reading on a clock can be changed without making any corresponding changes in time. So, clocks are just indicators of elapsed time. They are not direct measures. Similarly, thermometers are used as indicators of temperature. But the reading on a thermometer can be changed without making any corresponding changes in the weather. So, thermometers, like clocks, are just indicators of elapsed time. They are not direct measures. These observations are important because they apply especially to many kinds of situations that occur in the social or educational sciences. For example, developing deep understandings of important concepts in a course may lead to higher test scores. But it is well known that efforts to increase test scores do not necessarily contribute to deeper understandings of important concepts in a course. In fact, especially in cases where lists of measurable attributes are used as indicators of achievement, changes in these indicators often do not add up to improvements in important kinds of achievement. Examples are easy to find in curriculum standards documents, such as the USA's newest Common Core State Curriculum Standards, where most higher-order concepts or abilities are specified only as names for lists of lower-level facts or skills. For example, in nearly any sports or performing arts, it is well known that mastering a list of basic skills does not make you a champion. More complex activities, such as scrimmages, or practice matches, or practice recitals also are needed. And, during these complex activities, paying excessive attention to detailed skills can actually have a significant negative effect on performance. To quantify attributes like the ones shown below, the goal is to operationally define relevant constructs, not simply to find indicators of their occurrences. But many attributes cannot be measured directly. So, to define them in measurable ways, it is useful to notice that a. Many of the items in the list above are ness attributes, and b. Most ness attributes tend to be operationally defined in ways that involve quantities, like rates, miles per gallon, or calories per donut. That is, they involve relationships between two or more other quantities. Furthermore, many more items above are attributes, which also tend to involve quantities, and b. Many of the other items also could have been described as ness or attributes, even though they were not in the list above. Intensive quantity is a more formally correct term for what we've referred to as a ness or quantities. For intensive quantities, the quantity being measured is essentially a relationship between two extensive or intensive quantities. Examples include miles per hour, dollars per ticket, and other ness and quantities that we have considered. For extensive quantities, the quantity being measured can be partitioned into units which can be added. Examples include inches, centimeters, mass, apples, oranges. For nominal quantities, the quantity being measured is assigned a name or an address that allows instances to be compared in certain ways. One distinctive characteristic of intensive quantities is that they are scalable, but they cannot be counted. Scalability means that, if a whole quantity is broken up into parts, then the measure of each part is the same as the measure of the whole. For example, if the density of some materials is d, then the density of each of its parts is also considered to be d. So, if the density of one part is d, and the density of another part is also d, then the density of the two parts combined is not d plus d. It's just d, because the relationship is the same for the whole as for the parts. Scalability is an important property, but it also leads to an important problem. For example, intensive quantities like density may vary throughout a space, but it still may be important to measure the attribute at some specific point in time. Intensive quantities like speed often vary from one point to another, but it still may be important to measure the attribute at some specific location. What's problematic about these situations? Speed is about changes in distance compared to changes in time. So, what does speed mean when there is no change in time? Similarly, density is about the amount of some quantity in some given area. So, what does density mean at a point, which is no area? These problems were solved, for some restricted situations, through Newton's invention of calculus. But, like all such solutions, the use of calculus is based on assumptions which can strongly restrict or influence conclusions that are reached. So, it is important to be aware of some of the most important of these assumptions. Calculus, yuck, but don't panic. The main things that we need to notice can be seen in the situation about the toy car that you already saw earlier in this unit. At this point, you have enough information to revise your system of recording and organizing examples of different kinds of quantifiable attributes that occur in newspapers like USA Today. So, you may want to stop this video here and finish that assignment. But then, 2 more follow-up videos are given in these homework materials. The first focuses on a strange but important type of intensive quantity that is similar to speed at a point, in time or density at a point in space. The second focuses on methods for operationally defining constructs that cannot be observed directly, and that may change in fundamental ways when they are observed indirectly.